So when we talk about network surveillance, we're talking about being able to cover the various portions of your network, whether it be wired or wireless, managed or unmanaged. And we're also going to be talking about the basic information, the who, what, when, where, how of a device and its compliance status, and to identify whether it's unknown or misconfigured or rogue. So those are the basics of network surveillance. What we're going to be talking about a little bit more today is how device platform intelligence can enhance typical network surveillance and provide additional actionable information, especially valuable in the IoT era. So let's talk about what is device platform intelligence and what information does it provide. We've already identified that this information is critical and it's important to have. So you need to have information about what is connected to your network. However, the quality and the extent of that information is what will determine how that information is actionable and how you can craft your network access control policies. When we think about legacy device fingerprinting, really devices typically get identified and thrown into buckets or categories, and then there is some action performed. The difference between device platform intelligence is that it's actually its own entity. So this is a highly correlated database that correlates information above and beyond just high-level device type. You're going to get information about the manufacturer. You're going to get actual pictures of the devices. You're, of course, going to get your typical information about where the device is connected. You'll get the manufacturer country of origin. We're going to be focusing a lot today on the end of sale, end of support capabilities of DPI, as well as the ability to link specific platforms to vulnerabilities. So this information is one of the things that distinguishes DPI and makes it a next-gen device fingerprinting platform and differentiates it from legacy device fingerprinting. Also, one of the common themes we'll be talking about today is that there is no complex network integrations required to obtain DPI for active nodes on the network. And we'll explain a little bit more about how that's possible. So I talked about how DPI is really its own product. So what it does is it correlates information in a cloud database maintained by Genians that has been built for over a decade that gets updated weekly. We've added over 4,000 platforms in 2019 alone. It's also a searchable database. You can actually search for products, find out more information about specific products. You can even screen devices before you connect them to your network. And we directly link CVE information to the CVE website where you can, the NIST.gov website where you can review details of CVEs. You can also suggest platform updates through the interface. So this type of information is definitely not legacy fingerprinting. This is what we consider next gen. Seeing a picture of a device, getting information about end of sale, end of support, knowing how it was fingerprinted, knowing where the manufacturer is headquartered, having this searchable database for specific platforms, and then also specific vulnerabilities that are linked to platforms already in this database without any additional configuration or work by the customer using the product. That is what we consider next gen. So continuing along the lines of the vulnerabilities and how important those are, I'm sure this product list here is going to look familiar. So just about everyone, I'm sure, has multiple products in this list on their network right now. And if you look at the number of vulnerabilities, the severity of vulnerabilities for these products, that is a cause for concern. So the challenge that cybersecurity professionals and managers have had is how do you actually sift through this information? How do you easily make it actionable? And going through thousands of lines of vulnerability scanner reports is one of the things that has been documented over and over again as being prohibitive and non-productive, and therefore devices that are vulnerable just sit on the network.
Interesting. Brett, if I may, a question. The information pertaining to correlating CVEs seems particularly valuable. Is there a way to make this information actionable In other words, if a device connects to the network that is correlated with the CVE, will some kind of action based on that information then be performed?
There certainly is. So that actually is the challenge, right? How do you make it actionable? So what we'll cover here in some subsequent slides and in our demo, we'll show how that information can be actionable. Having this information is only as good as the ability to do something with it. So we've determined now that this information is critical. We determined what this information is that we want to obtain. Now we can discuss how do we obtain that information from the network. If we look at the architecture of a typical Genie and NAC on-prem deployment, cloud deployment is almost identical, the exception of your policy server being in the cloud instead of on-prem. One of the things that differentiates this solution from other similar solutions is the ability to non-intrusively collect a bunch of this low-level information that feeds the device platform intelligence database and identifies those specific platforms that are on your network. So being able to get this information without actually having to touch all of your networking equipment, configure high availability because you've got a single point of failure, and do this easily without a lot of networking knowledge or having high-level networking experts involved or network access control experts involved. That's always been the challenge. So with the sensor approach, you're able to quickly and easily connect a sensor to various locations in the network, and then it starts to passively collect information about all active nodes. You can detect up to 128 VLANs per sensor, and what that gives you is the ability to, either in a passive or an active mode, monitor ARP broadcasts and other traffic that feeds the DPI database and allows you to know what platforms are identified on your network. That information is then automatically correlated to vulnerabilities and end of sale and of life information. If we contrast this to some other methods, so for example, we're using Radius here, what you really have is a much more complex integration, even just to get basic information like Radius accounting that tells you that devices are connecting to your network. So for this type of architecture, you have to touch every switch or controller or access point. You have to point that information to the Radius server. You typically have to configure high availability because now you have a single point of failure. And this is a very intrusive, high touch architecture to implement. And that's just for basic visibility. On top of that, to get more information, you typically have to integrate with DHCP servers to be able to get DHCP fingerprinting information or configure profilers on your switches or other devices to profile information. And again, that's really only for basic legacy, what we consider legacy device fingerprinting. In subsequent webinars, we're going to be taking a deeper dive into all of these different types of NAC architectures. But the one thing to note is visibility, right? Being able to identify networks, devices that are on your network, that is the key. That's the focus of this webinar. And that is actually should be the first focus of any good cybersecurity plan, is to know what's on your network. So some of these other architectures are very intrusive and have a bunch of considerations and challenges. Configuring all your devices, high availability, may not be vendor agnostic. You have to have switches that support features. Every time you refresh your network, you may have to reconfigure things. Is it low touch? Can it be cloud managed, et cetera, et cetera. So one of the things about the sensor architecture approach is it addresses almost all of these concerns. You may need to implement a sensor at every location depending on your architecture, but aside from that, really all of the other concerns are mitigated by this architecture, and it gives you very quick visibility into your network without a network integration team of professionals.
So powerful stuff, Brett. Let me just take a moment and confirm what I hear you saying regarding how DPI is obtained from the network. There's no network changes at all required, right?
That's correct. So typically what you have to do is you have to configure all of your network devices to feed whatever system you're using to fingerprint devices or integrate with DHCP servers or other profilers. In this case, really the only thing you have to do is connect the sensor to your network with either an access or a trunk port, just like you would a server or a switch. So really only basic networking skills required and no real network integration needed.
Okay, great. Thank you.
Mhm. Let's talk a little bit about how DPI obtains the information that it obtains. So there's a passive mode and an active mode. So in a passive mode, there's a surprisingly large amount of information that gets generated by any device that connects to your network. So one of the first things that it's going to do is a device is going to send out ARP broadcasts to find out what its gateway is, to find out other information. So even in passive mode, just listening to this information, there's X amount of information that can be extrapolated from the traffic that's generated, along with some additional secret sauce we're not listing here, that can actually help us identify and link a device with a particular platform type. And remember, platform is not device. We'll talk about that more. Device type is very high level, platform is very low level. If you go into an active mode, we actually get more granular information. So you can enable scanning and use other methods that will further enhance and refine the initial platform detection and maybe refine it down to a more granular level. So this is typically implemented in a staged fashion, but neither one of these requires any network integration. So typically what most customers do is they turn it on in passive mode. They identify a bunch of platforms on their network. If they feel they need additional information, they can go to active mode, which will give more granular information. And then optionally, you can enable policy enforcement once you're in active mode. We'll talk more about that in subsequent slides. Okay, knowing that this information is important, knowing that it is easily obtained from the network, now that we have this information that's very difficult to obtain typically, but not with Genians, what do we do with it? How can we enhance our NAC policies with the DPI information we've obtained from the network? We've got 3 use cases here. There's many. This is just to demonstrate the difference between what is typically what we consider a legacy approach relative to identifying devices and fingerprinting them on the network, and how device platform intelligence can differ from that. So because you have increased granularity about specifically what kind of platform it is, you're not talking about a basic category and you're able to get more specific. So many times relative to printers, you'll have a printer fingerprint, it'll get classified as a printer, and there will be an action performed like put it into a printer VLAN. What you can do with DPI is you're going to be able to distinguish between all of these different printers, manufacturer, make, model, etc. And then you're able to actually do something with that information. So you can define authorized printer platforms and unauthorized printer platforms, and then you can actually assign specific permissions. Those permissions follow that platform no matter where it goes on the network. Because the permissions are set in the software, you don't have to apply ACLs or deal with radius or touch your network at all. This is software-defined permissions that are enforced by the Genie and NAC system. Now you may think, well, what does this really buy me? Most printers out of the box today have things like HTTP enabled. So one of the huge things that gets brought up over and over again as far as preventable cybersecurity issues is having devices with HTTP enabled on your network. So perhaps there is a specific printer manufacturer model that you want to allow on your network, and you know it's been vetted, you know it doesn't have vulnerabilities, and you don't want to allow just any HTTP enabled printer on your network. You want to be able to restrict that or deny that. This use case can address that. We'll look at this live in the system momentarily, but basically you categorize your devices. You have authorized printers, can be your specific platform, and then unauthorized printers can be all other printers that are not part of this specific, not this specific platform. Once you categorize that, then you can actually do whatever kind of permissions you would like to do. So in this example, you're restricting access to the internet, so your internal network cannot be compromised, but that of course could be a deny all permission. This is not very complex. You don't need to be a NAC expert or a networking expert to be able to configure these policies. Another use case is for end of life, end of sale, end of support platforms. So when we talk about legacy fingerprinting, this information is typically not part of the picture at all and not available. So a device type is normally assigned and that's it. So if you are able to do this, typically it's going to require some kind of a third-party integration if available, and then that may cost more, and then there'll be some kind of action like assign a VLAN. With DPI, because you have more granular information, you're able to link specific platforms to an end of sale or end of support or end of life. You're able to group those together, restrict access, and the permissions follow the platform around. So again, the key here is being able to assign specific platforms. That gives you the power to be more granular with your network access control policies, and you can restrict or deny any end of sale, end of support device on your network. So what you can do here is configure end of life states. You could say end of sale, end of support, or we even have an out of business category because we're tracking that. Once you group those together, then you assign whatever permissions you like. So in this example, it's internet only, or you can just say permit all while you're just monitoring or looking at devices that are end of sale, end of support that you want to proactively remediate before you get into too much trouble. And then our final use case here is for vulnerabilities. So this is what I consider one of the most powerful features with device platform intelligence and next-gen device fingerprinting is to be able to pre-correlate and pre-link devices with vulnerabilities. So again, legacy fingerprinting, this is not a feature that typically comes with it. So the third-party integration, if there is one available, there may not be. You may need to have a network access control system and then separately have a vulnerability scanner. And what happens then is you run into the problems we discussed at the beginning of the webinar, where you have thousands of lines of a vulnerability report that you have to go through. And many times that takes too much staffing, just doesn't get done. And as a result, there's a bunch of vulnerabilities that are on your network. So with DPI, because again, we actually have that pre-correlated in the DPI database and it's tied to the specific platform, you can group these together. Then you can decide what to do, restrict or deny access, and the permissions are in software, not on the network, so they follow that platform around no matter where it goes. That's the common theme. With Genie and NAC, you're going to leverage device platform intelligence to actually know any and all CVEs that are published and whether the nodes on your network are affected. So every single CVE that gets published will be listed. You can determine whether or not any nodes are applicable, and then you can drill down and take action. So if you see a CVE published and you see 0 nodes, that means there's no nodes active on your network that are affected by that CVE. You don't have to worry about it. Once you find a node on your network that is actually affected by a particular vulnerability, you can dig a little deeper and you can see what the vulnerability is. So we have a device, we have some end of sale information, but this example is going to be specific to a particular CVE where this camera can allow anyone to view audio or video without authenticating. So that's a pretty critical vulnerability. We can actually create a group and we can tie platform security vulnerability to a particular vulnerability ID. So that's very powerful. Not only do you know that it has vulnerability, but it's a particular vulnerability, and then you can define whatever permissions you want. Once you group that together, you could say this is a particularly nasty CVE, so I just want to deny all for any device that may be affected by this CVE on my network. So now we're going to go ahead and take a quick tour of the UI and look at some of these configurations live and discuss some other items.